Thank you, Mr. Chair. Ladies and gentlemen, I am Neville Azzopardi. I'm part of the research department of Abertax Technologies. Today I will be showing you a project we have done at the University of Malta together with Abertax Technologies and Andrea. The project is mainly speaking on a micro-hybrid CHP combined with PVs and various energy storage solutions to provide household energy needs. As we have spoken this morning, there is the energy crisis, and we decided to tackle it from the consumer side rather from the generation side. First of all, we started with an energy audit of a number of households, both in Northern Europe and Southern Europe, and divided the consumption in a house into 4 different categories. Mainly lighting and communication, which resulted in 4% of the total energy demand of a household. Cooking, which results in 10%, appliances, 20%, and the largest consumer, of course, is heating and cooling. Both for space heating and cooling and water heating is then only 15%. So we started with the smallest problem, let's say, by making a solution for the lighting and communication circuit in the house, which is a very small percentage. Therefore, the investment needed is very small, since you only would need 2 PV panels, a very small storage battery of 1.5 kilowatt hour, very small inverter, and all the lighting and communication can run completely off-grid. I have this in my house, working for 2 years, and it works wonderful, especially when there are power cuts. You can still keep on going with the things which are very essential, like lighting and communication nowadays. Also, we noted that putting the PV panels in vertical rather than the 20 degrees we have in Europe would be better, because you would have better performance in winter and less performance in summer when light is more abundant, so you would need less energy. Then we studied 3 main solutions for heating and cooling. So we're going to the big energy consumer in the house. And we've come up with these 3 energy generation solutions and studied their performance both economically and so taking the scenarios of the feed-in tariffs and gas and electricity prices before and after the Ukraine war started. Basically, we've taken the case where you have a gas power plant. The electrical energy is then used to heat with a heating element. You have 45% efficiency. If you then use a heat pump, you get much higher efficiency, up to 135%, due to the high COP in the heat pump. The next is also a quite high efficient system using a condensing boiler. And the third scenario is using the micro CHP, which we designed in this project. The micro CHP, you have 2 energy outputs, electricity and heat. So the heat is directly used to do the space heating. And the electricity, we've taken 3 different scenarios. You're using electricity to export it to the grid, electricity to heat using a heat element, and the most efficient, of course, again, using the electricity generated via heat pump. Thing to note also that the CHP is running at 85% efficiency, which is quite high. The best scenario economically of all these cases is running the micro CHP with a heat pump, of course. But this varies depending on legislation and country you are in. So now we went to different storage possibilities. One's automatic solution would be going to batteries. Lead acid or lithium are very used nowadays. But we have also looked at other areas where we can store our surplus energy, mainly in stone and also water. We were amazed, in fact, to find that water can store for the same volume, the same amount of heat as a lead acid battery. And the volume taken by lithium is much larger, especially if you use high voltage lithium, which is very common today, due to the space needed for an extra inverter and larger casing. Here we see the results. So taking all these different, considering storage solutions, we considered an apartment of 150 square meter with a height of rooms being 2.9 meter, and found that 120 kilowatts can be installed in the internal dividing walls in the brick, 350 in the side walls separating the property from third parties, 256 kilowatt hour in the front and back side of the building, 238 in the floor slab, 2 kilowatt hours in the air, since air doesn't store a large amount of energy, of course, and 35 kilowatt hours of this energy in hot water. So here you are not investing in batteries, but using what you have in the house, which is water storage and the building itself, to store your excess energy. So this is the specification of the CHP we've built. It's a very small CHP which can also fit in the cabinet of a kitchen. It's in fact 60 centimeters wide. It has an electrical output of 2 kilowatts and a peak heat output of 5 kilowatts. After, in the graph is shown here below, after 1 hour of operation, we can heat up 200 liters of water, an increase of 60 degrees. And since it is very efficient, the exhaust temperature is only 50 degrees. This is why we managed to achieve such a high efficiency, because all of the heat is being recuperated and transferred to the water for heating. Next is a schematic of the system. So we have the CHP, which is at the center, has a small battery which is used for starting the engine, but also used for the lighting system, which I showed in the second slide, powered by the small PV, very small PV system. Then you have the PV panels, which are generating a 3 kilowatts peak of power. These can be connected both on-grid and off-grid. So in a normal situation, you have, while we are connected in on-grid, you can have the PV panels exporting energy to the grid, the CHP also exporting. But in case of a power cut, which is quite common nowadays, you can still run the essential equipment in the house by running the micro CHP and the PV panels in a micro grid situation. We also included a heat pump in this system to gain higher efficiencies. These are some pictures of a system we have installed in a household in Malta. So on the right hand side we see the CHP, which is the small unit, and next to it there is the water tank, which is used both as a buffer tank and a water storage tank for the hot water in the house. On the left, on the top, we see the heat pump, and on the bottom we see the room where they are installed, so you don't need much space to install the system. And on top of that room there is the 3 kilowatt PV system, and there are the 2 panels, extra panels for lighting, which are not shown here. So these are the results. After running the system for a year, we monitored the energy in and out of the house. So the blue part on top shows the energy coming in from the grid. The yellow-greenish is the self-consumption part, and the purple part is the energy exported. As expected, in winter we have more usage of energy from the grid, while in summer we have a lot of export coming from the 3 kilowatt PV system. Conclusion. So we have shown various possibilities to store energy in a house and integrate them with PV and the micro CHP. And we also have found that the best solution to decrease the LNG consumption in a house is, of course, to use heat pumps, but the micro CHP will also work a lot together to increase the efficiency and reduce the costs. Thank you.
I have a question. What is the price of the CHP regulator?
Price, I would ask the help of the author, please, because I'm more in the engineering side, but pricing.
Okay. It's a challenging question. At the moment, it's very difficult to say the price of this. We have a patent underway, and we are trying to produce it so that at the end customer, including the battery, will cost around 5,000. So it's very easy to maintain because it uses low voltage. So anybody can really lay his hands into the maintenance because it's only 48 volts, so it goes under the low voltage criteria. So
5,000 was with the solar panels?
No, it's the CHP. The solar panel is something additional, so that if it is in summer, if it's summertime, the battery can still, the local battery inside the CHP won't charge by switching on the heat pump because, by switching on the CHP because you don't need heat in summer, but can be charged easily for the lighting and communication as he explained using 2 solar panels. So this is extra, the solar panels.
The CHP is just used for the heating?
For the heating and the electricity generation.
Also, yes.
So it generates 2 kilowatt-hour, 2 kilowatts at all times.
Okay.
It all depends on the tariffs you have. So if you have a very good export feed-in tariff, you would use the CHP also for that.
Okay.
All the system, as I've shown, is very dependent on the energy policy of the country or in the scenarios have to be worked out for every situation. In fact, future work we will do is to make a smart controller for all the system so that it can adjust the usage of PV or the CHP depending on the energy price and the efficiency, of course, to get the best, lowest energy price in Thailand.
And how noisy is this generator?
Well, it's very well insulated, although the casing is very small, it's very well insulated and it's not very...
55 decibels.
55 decibels to be exact, yes.
When it's running at full power. But the advantage is that since it can be controlled via mobile communication, you can switch it on even when you are not in the house.
Yeah.
You can switch it on via an app and have it running for 1 hour, I think it's enough, 1.5 hours.
Okay, interesting. Did you do any calculation to see how many years you need to do the break-even, basically?
Well, it depends on the tariff, of course. In Malta, the tariff is very low, but in Germany, if you put it in Germany, I think it's around 2.5 years will be the return on investment.
Interesting.
Yeah, one has to remember this is one of the few, if not only CHPs, that can be switched on when there is no grid, which is very important because, as you know, most equipment in the house, even with a condensing boiler, needs some electricity to run. So basically, what there is experience now in, for example, Ukraine, with having no grid, means that you also have no heat. So it's important to keep in mind that a little bit of electricity in a house to sustain all the systems in running is very important because everything needs some electrical source of energy. And well, unfortunately, most of the CHPs that are available on the market, small or large, do not switch on if you don't have the grid. This is different.
Yeah.
In fact, this is really like a hybrid car. It is not actually producing any AC, it's the inverter that will then generate the AC. This is DC, and it is basically a mixture between chemistry, because you have the battery, and fuel in the tank. And you can mix those as much as you like, and depending what are your needs.
Yeah, that's great. I'm hoping the guys can continue make it a commercialized product. Basically, rather than
We are
stay
on
as
the
a
way.
kind of
No, we are on the way.
research.
It should be commercialized by middle next year. So
Okay, that's great.
we are at the moment certifying it in Germany.
Good to hear that. Thank you
Thank
very
you.
much.